Welcome to the Deep Dive. Today we are staring down one of the most immediate and, well, profound challenges facing the planet: the rising tide of plastic pollution.
It's a topic where we often get caught up in the extremes.
Exactly. Either the doom of the problem or, the hype of a single solution.
That's right. And the source material we have today is a colossal stack. Our listener wants us to move way beyond the headlines. It's dominated by the recent, and I mean highly detailed, Breaking the Plastic Wave 2025 report.
Okay.
But that's paired with deep research on everything from the political economy of plastic bag bans to, well, groundbreaking discoveries of deep-sea enzymes. It's a journey that spans from the UN negotiating table all the way to the deep ocean floor.
So our listener, the learner, is looking for a thorough, unvarnished assessment of all this. We need to define the scale of the impending crisis, the business-as-usual trajectory. But then, crucially, we have to provide the realistic, concrete blueprint for the pathway forward. The system transformation. We're looking for facts, yes, but also for viability and, I guess, the trade-offs involved.
Exactly. The core mission today is to compare those two paths: the frightening business-as-usual scenario on one hand and the ambitious system transformation on the other.
And then see how it all fits together.
Yes, and then evaluate how effective current cleanup efforts really are and where all this cutting-edge innovation, both chemical and biological, fits into that 2040 vision.
Okay, let's unpack this. Let's start with the sheer scope of the crisis we are facing. If the global community collectively chooses the path of least resistance, business as usual. Because the speed at which this problem accelerates is almost, well, it's incomprehensible.
It truly is. When the report models the business as usual, or BAU scenario, they're assuming virtually no new ambitious policy measures are enacted globally.
So just more of the same.
Pretty much. They assume that waste management capacity will continue to grow, but only in lockstep with expected economic and population expansion, which means our habits remain the same, just, multiplied by more people and higher consumption.
And what does that mean for the volume of plastic that leaks into the environment annually? Let's get the numbers. Give us the starting point for 2025 and then the grim projection for 2040.
Okay, so as of 2025, the annual figure for plastic polluting the environment, and that's everything that isn't collected, properly landfilled, or recycled, already stands at 130 million metric tons. Or
130 million tons. Every single year. That's the baseline.
That's the baseline. And if we stick to BAU, that figure will almost exactly double. The projection for annual leakage by 2040 is a staggering 280 mount.
Doubling the annual pollution rate in just 15 years. That's not a steady climb. It's exponential growth.
Yeah.
It means we are falling further and further behind every single year.
Yeah, and the visual they use is probably the most arresting part of the analysis. To help you really understand the sheer momentum of this acceleration, the report calculates that this increase is equivalent to dumping nearly a garbage truck full of plastic waste into the environment.
A garbage truck.
Every single second of every day. It's a relentless, high-volume flow of material that our ecosystems simply cannot process or absorb.
So why is this growth so explosive? If waste management is expanding, even if it's slowly,
Yeah.
why is the pollution accelerating so rapidly?
It's a massive systemic mismatch between what we make and what we can process.
Okay.
The doubling of pollution under BAU is driven primarily by soaring primary plastic production, just completely overwhelming our woefully inadequate waste management systems.
So we're just making too much of it to begin with.
Way too much. Global annual primary plastic production, that's virgin plastic, essentially made from new fossil fuels, is projected to rise by 52% under BAU.
52%.
Yes, from 450 mallet in 2025 to 680 mallet in 2040.
52% more plastic being created. That's an enormous economic commitment to the status quo.
It is, and here's the key point. While production balloons by 52%, the waste management capacity, so our ability to collect, sort, and process, is only expected to expand by 26% during that same 15-year period.
Wow. So that's the gap.
That is the gap. That 26% difference between what we produce and what we can handle is the reason the pollution figure doubles. The waste stream is simply too large for any current or, frankly, projected infrastructure to handle.
And which regions are responsible for creating this tidal wave of virgin plastic, because that really dictates where the systemic solution needs to begin.
Well, high-income and upper-middle-income economies absolutely dominate this upstream landscape. They account for nearly 80% of global virgin plastic production in 2025.
80%?
80%. So while plastic use and production are growing rapidly in lower-income nations, the sheer volume, the innovation, and the infrastructure that drives primary production reside overwhelmingly in the world's wealthiest economies.
Which makes the pollution problem fundamentally a design and, I guess, a responsibility issue for the global north.
That's what the data suggests.
Let's pause on that figure for a moment. 80% of the flow originates from economies that theoretically have the financial and political capital to change their systems. So the decision to continue this BAU trajectory is not some technical failure in the global south.
No, it's not.
It's a political and economic decision being made in the global north. Now let's talk about the catastrophic externalities of this production model, starting with climate change.
Right. If the plastic system continues on this path, it is not just an environmental crisis. It becomes a fundamental obstacle to any climate goals.
How bad does it get?
The annual greenhouse gas, or GHG, emissions from the plastic system will surge by 58% by 2040, reaching a total of 4.2 gigatons of carbon dioxide equivalents, GTCO2e.
4.2 gigatons. That number is it's staggering and is often paralyzing for the average person. Can we connect that to something more familiar for you, the learner?
Absolutely. To make that figure tangible, 4.2 GTCO2e is equivalent to the annual emissions of approximately 1 billion gasoline-powered cars.
1 billion.
1 billion. So if the plastic system were a country, it would be among the top 5 global emitters within 2 decades. This trajectory, by itself, sabotages global commitments to limit warming to 1.5 degrees or even 2 degrees.
And we often assume those emissions come from plastic waste just sitting in the environment. But the report stresses that the vast majority comes from the initial stages.
That is the critical insight. The production stage, refining the hydrocarbons, creating the monomers, polymerization, product molding, that accounts for the overwhelming majority. 86% of all plastic-associated emissions in 2025.
86%, so it's baked in right from the start.
It is. This is because plastic is almost entirely derived from fossil fuels, making its creation incredibly energy-intensive. When we talk about the climate impact of plastic, we must first address the oil and gas industries that feed that production line.
So the production line is the fundamental climate killer. But the sources also identify a massive, and I mean immediate and geographically focused, driver of emissions later in the life cycle.
That brings us to the tragedy of open burning.
Right.
So while production is dominant overall, the mismanagement of waste, specifically open burning in communities without formal collection, is the largest source of later-stage emissions. Open burning contributes 43% of those later-stage emissions in 2025.
And it gets worse.
It gets much worse. Alarmingly, because waste management expansion is lagging so far behind, the share of emissions from open burning is projected to rise to 59% by 2040 under BAU. Emissions from this source alone will increase by about 160% in that period.
That is not just a climate issue. That is a profound social justice issue. Open burning exposes local, often vulnerable communities to immediate toxic health threats. What specifically does the research identify regarding those health risks?
The research is clear. The global plastic system puts specific, vulnerable populations at severe risk, primarily those living near production sites or open dump areas.
And the toxicities in the additives.
It's driven by the chemical additives used to give plastic specific properties. For instance, in a model analyzing a typical plastic product, researchers found that flame retardants and plasticizers chemicals used for flexibility or fire resistance accounted for about 3/4 of the modeled potential harm.
3/4.
Yeah. And these substances can leach out, causing chronic health problems, including endocrine disruption and neurological damage, long after the plastic has even been manufactured.
So just to recap this bleak picture, we have a system where high-income economies drive 80% of a production process that is a massive climate threat.
Correct.
And the resulting failure to manage that waste leads to a massive growth in localized toxic open burning in low and middle-income communities.
Yeah.
If the BAU trajectory is that destructive environmentally and socially, we have no choice but to radically transform the system. So what does that transformation look like?
This is where we shift to the system transformation scenario. And it's an integrated, holistic, and importantly, global approach. It recognizes that solving this problem requires action at every single stage.
Before, during, and after.
Exactly. Before plastic is created, so upstream, during its use, and after disposal, downstream.
What's the ultimate critical goal we need to hit by 2040 to say we've truly broken this plastic wave?
The goal is an 83% reduction.
Ah,
The system transformation scenario could reduce annual plastic pollution entering the environment by a truly staggering 83% by 2040 compared to that BAU path.
so it's achievable.
It's achievable, but it requires coordinating 7 major intervention areas globally, simultaneously. It's a huge undertaking.
An 83% reduction is essentially halting the acceleration and beginning a profound decline. What are the systemic benefits we reap if we achieve this?
Wow.
It can't just be about the plastic.
Oh, the benefits are manifold. They move far beyond just pollution reduction. On the climate front, we'd see a 38% reduction in annual GHG emissions from the plastic system.
38%, that's significant.
It's very significant. On the social front, there's a substantial 54% reduction in modeled annual health impacts. And financially, the system becomes more efficient. It translates to a U.S. $19 billion decrease in yearly government spending globally on collection and disposal by 2040.
So governments save money.
They do, because less plastic is leaking and more is being circulated efficiently. It's an economic win-win.
Okay, let's look at the pillars of this transformation, starting where the greatest leverage exists. Pillar 1, reduce and reuse. If we want that 83% cut, where do we start upstream?
We start with packaging. Simple as that. Plastic packaging is by far the largest source of plastic waste. Under system transformation, pollution from plastic packaging can be nearly eliminated.
Nearly eliminated.
Yeah, decreasing 97% by 2040 compared to BAU. It would fall to less than 2 million metric tons globally. That is the single greatest sector success projected in the entire report.
How on earth do we achieve a 97% reduction in the largest waste category? That sounds almost impossible given current consumption habits.
It hinges entirely on what they call the reuse revolution.
Okay.
The data is unequivocal. Reuse accounts for 2/3 of the total projected decrease in plastic packaging waste by 2040. This isn't a marginal solution. It is the central transformative mechanism.
So it's not about better recycling, it's about not needing to recycle in the first place.
Precisely. By embracing reuse models, primary plastic production for packaging could drop by 76% compared to the BAU scenario.
That figure, 2/3 of the cut coming from reuse, that is the single most important metric for you, the learner, to remember. It defines the solution. But just reuse more isn't a policy. What are the policy levers that actually drive this seismic shift?
The most powerful levers are government-mandated return and refill-based reuse systems.
Right.
These drive nearly 2/3 of the packaging waste cuts. The key complexity, however, is that these systems cannot be a one-size-fits-all solution. They have to be context-specific.
Give us an example of how the context dictates the solution. What does that look like on the ground?
Okay, so consider 2 different regions. In Western Europe, a viable model might involve high-tech, centralized washing and bottling infrastructure, backed by really robust logistics.
Very organized, very top-down.
Exactly. But in a country like India, success is built around repurposing and formalizing the existing sophisticated collection and sorting activities that are already performed by millions of informal waste pickers.
So you work with the system that's already there.
You have to. The system needs to provide infrastructure and standardized contracts to them, rather than building an entirely new formal structure that might just displace those workers.
That emphasizes that the environmental solution has to be integrated with social justice. It can't be one or the other.
They're inseparable.
Beyond mandated reuse systems, what other upstream actions are necessary to curb the flow of virgin plastic?
We need broad upstream actions. The source material lists a few key ones. Regulatory bans on particularly problematic polymers that are just too hard to recycle.
Like
Things like PVC or polystyrene foam. Then you need product design requirements that mandate minimal monomaterial packaging, so it's easier to sort and recycle.
Makes sense.
And then there are targeted taxes on all single-use items and mandating the provision of packaging-free alternatives in retail spaces. Fundamentally, though, the sources argue for eliminating all subsidies for virgin plastic production.
Which currently make it artificially cheap.
Right. It completely distorts the entire market structure.
Okay, that leads us directly to Pillar 2, material circularity. Once plastic is used, we need vastly improved collection and processing capacity to ensure what remains in circulation is maximized. What are the targets for collection and recycling rates in this new system?
Under the ambitious system transformation scenario, macroplastic collection rises dramatically. It moves from a mere 66% under BAU to an ambitious 97% globally.
97%. So almost all waste is captured.
Almost all of it. In parallel, the global recycling rate more than doubles, increasing from 17% under BAU to 34% by 2040.
Okay, I have to ask, why only 34%? If we are transforming the system, why isn't the recycling rate higher? Is that a technical ceiling we're hitting?
It's a combination of technical barriers and, more importantly, the priority given to reuse. Remember, the system transformation prioritizes reduction and reuse first.
Right, that's the 2/3.
Exactly. The remaining 34% is what can be economically and sustainably recycled. And critically, we need to focus on smarter recycling.
What does that mean, smarter recycling?
It means the share of plastic waste recycled via closed-loop mechanical recycling. That is, making the same product into the same product, like a peat bottle into a new food-grade pea bottle rises from 36% to 57%.
Ah, so you're keeping the quality high.
You're ensuring the material maintains its value rather than being downcycled into, park benches or low-quality products.
Let's address the elephant in the recycling room. Advanced or chemical conversion? This is a massive industry battleground right now. What is the chemical conversion reality check provided in the source material?
Right. Chemical conversion technologies are seeing massive investment. It's primarily focused on plastic to plastic, or P2P conversion.
And what's the goal of P2P?
P2P aims to chemically break polymers back down into their original monomer building blocks or petrochemical feedstocks. So you're effectively creating virgin equivalent plastic. The industry projects rapid growth, a potential 40-fold increase in capacity for packaging plastics over this 15-year period.
A 40-fold increase sounds like it could save us. Is this the silver bullet that bypasses all the complexities of mechanical sorting?
Not yet, and certainly not by 2040. The report provides a crucial reality check on this.
Which is?
Even with that rapid industry-projected growth, P2P conversion still accounts for less than 0.1% of all reprocessed plastic by 2040.
Less than 1/10 of 1%.
Exactly. This highlights significant persistent barriers, things like the massive capital cost of building conversion plants and the ongoing difficulty in reliably sourcing the high-quality, pre-sorted, and contamination-free feedstock that these chemical processes require to be efficient.
So it's promising for the really hard-to-recycle materials, maybe, but it is not a large-scale solution for the bulk of the waste stream in the next 2 decades.
That's the assessment.
What about the other major chemical conversion method, plastic to fuel, or P2F?
P2F involves pyrolysis or gasification to convert plastic waste into liquid fuels like diesel or gasoline. This is a robust and growing market, particularly in high-volume, consumption-driven economies like the U.S.
How big is that market?
It's estimated to reach nearly $285 million in the U.S. by 2032. Industry likes this because it immediately solves the waste problem while contributing to energy needs.
But doesn't P2F conflict fundamentally with the circular economy goals? I mean, if we break down plastic into fuel, we are feeding the GHG emission stream and the fossil fuel economy, not closing the loop.
That is the core conflict. P2F is a disposal mechanism disguised as recycling. While it diverts plastic from landfills and the environment, it contributes to global warming and the linear take-make-dispose model.
And it has its own problems.
It does. P2F processes historically face significant efficiency issues, struggling with high capital expenditure and lower economic profitability compared to conventional fuel production.
Yet, innovation is constantly trying to overcome these efficiency hurdles. You mentioned a new catalyst discovery at the University of Delaware. How did that scientific breakthrough specifically address the challenge of converting polymers into fuels?
So the challenge with breaking down plastic polymers like polyethylene in shopping bags is that they are long chains of carbon atoms held together by incredibly strong carbon-carbon bonds.
They're built to last.
Exactly. Breaking these bonds requires massive energy, usually high heat and pressure. The breakthrough involved developing a novel catalyst, a mesoporous emsene-supported ruthenium catalyst.
Okay, let's simplify that technical language for the learner. What does that mouthful of science actually do?
Think of the catalyst as a highly specialized molecular key. It unlocks those tough carbon bonds at a much lower temperature and pressure, acting as a shortcut. The mesoporous structure means it has tiny internal tunnels that maximize the surface area, allowing the ruthenium, that's the active metal, to interact intensely with the plastic chains. They were able to use this to achieve reaction rates nearly double those previously reported for this process.
This huge efficiency gain.
It is, and crucially, they achieved high selectivity. This means the process produces a high percentage of the desired liquid fuel product and minimizes undesirable byproducts like methane gas.
So it's a cleaner reaction.
Much cleaner.
Right.
So while P2F remains contentious from a circularity standpoint, this innovation demonstrates that the efficiency and technical barriers are being aggressively lowered, making the conversion of common plastics like LDPE into usable fuel faster and cleaner than ever before.
Here's where it gets really interesting. We focused on macroplastics, but the sources underscore the parallel, invisible crisis of microplastics particles less than 5 millimeters in size. What does system transformation do for them, and why is this pollution stream so difficult to cut?
Microplastic pollution, which includes primary sources like intentionally added particles and secondary sources from the degradation of large plastics, is a uniquely sticky problem.
And the numbers show that.
They do. The system transformation scenario does cut total microplastic pollution significantly by 41% by 2040. It reduces the annual flow from 26 mount under BAU to 15 mount.
But 41% is only about half the 83% reduction we achieved for macroplastics. Why the persistent difficulty?
It really highlights the challenge of controlling what are called diffuse sources, especially in high-income economies.
What do you mean by that?
Well, in 2040, under the best-case scenario, microplastic pollution is still projected to make up 92% of the total remaining plastic pollution in those wealthy nations. It's a challenge because the sources are so varied and deeply embedded in our daily lives.
Like what?
Tire wear, fabric shedding from our clothes, cosmetics, agriculture, it's everywhere.
Let's break down those major microplastic sources and the specific, targeted policy solutions outlined in the source material. Starting with tires, which apparently contributes the single largest absolute mass reduction.
That's right. Tire wear is a substantial source, and targeted actions achieve the largest absolute reduction, 5.6 melt. This reduction isn't about collecting the rubber once it's worn off.
It's an upstream solution.
It's totally upstream, achieved through stricter design regulations and mandated abrasion limits on tires themselves. However, the sheer volume of road traffic means that even with this reduction, the sources emphasize that abrasion limits will need to be continually tightened over time to keep pace with transport growth.
What about textiles and clothing, which shed microfibers every time we wash them?
Pollution from textiles is cut by a dramatic 85% in this scenario.
85%.
How? It requires a two-pronged attack. Upstream, it means implementing best practices in fiber and fabric manufacturing to produce textiles with inherently lower shed rates, so a change in material science.
And downstream.
Downstream, it means improving capture via filtration, requiring high-efficiency lint filters in domestic washing machines and specialized fiber capture in wastewater treatment plants.
And what about personal care products? Many countries have already banned microbeads.
Right. Pollution from personal care products, or PCPs, declines 91%. The initial success came from the most effective lever, which accounted for 65% of reductions, banning intentionally added microplastics in wash-off products like face washes and cleansers.
But that's not the whole story.
No. The source material warns that to capture the remaining stream, bans must expand rapidly to include leave-on products, such as certain cosmetics and sunscreens, where microplastics are often used as stabilizers or fillers.
Finally, we need to talk about pellets, the raw material, and microplastics in agriculture.
The loss of plastic pellets, the raw material, often called nurdles, from spills during transport and production, is a huge source of localized environmental catastrophe.
But it's solvable.
Totally solvable. Pollution from this source is nearly eliminated, reduced by 96%. This win is critical, considering that up to 7,300 truckloads of pellets were estimated to be lost annually in the EU alone under the BAU scenario. It's purely a logistics and supply chain management problem that can be fixed with stricter operational controls.
In agriculture.
In agriculture, where plastics are used in everything from protective mulch films to polymer-coated fertilizers, microplastic pollution is reduced by 48%. The solution involves banning intentionally added microplastics in those fertilizers and aggressively substituting plastic mulch with non-plastic alternatives like biodegradable films or natural materials.
The narrative for years has been that microplastics are the majority of the problem in the ocean. Yet the reconnaissance of the Great Pacific Garbage Patch, the GPGP, suggests something different in terms of mass.
It's important to look at both mass and count. Microplastics are indeed the most abundant plastic by count in the ocean. There are trillions of them.
But not by weight.
Not by weight. Large-scale reconnaissance of the GPGP revealed that 92% of the plastic mass, the actual weight, is still comprised of large objects, Macro and megaplastics. These are the nets, bottles, and sheeting that haven't fully degraded yet.
So if most of the mass is macroplastic, why do scientists argue that microplastics pose the greater overall risk to marine ecosystems?
It comes down to increased bioavailability,
Me.
meaning that while large objects are highly visible and cause direct harm like entanglement, microplastics pose a greater systemic risk because of their size. Their small scale means they can impact exponentially more species, from plankton all the way up the food web.
And they act like tiny toxic sponges.
Exactly. Ingested microplastics can cause physical damage, but critically, they also absorb and carry harmful chemicals, pathogens, and parasites throughout the food web. They are a silent, pervasive threat that permeates the entire ecosystem, whereas macroplastics are a more localized physical threat.
This raises an important question that cuts across every pillar of the transformation plan. Who manages this complex global system change? And what role do the people, the workers, the communities play outside of these high-level policy negotiations? We need to look at the human element and the governance structures that either enable or prevent success.
The human element is the engine of the system transformation, particularly the informal waste sector.
Right.
If we are going to achieve a 97% collection rate, we must formally recognize and empower the nearly 12 million workers globally who are currently engaged in collecting and sorting plastic waste, often in very hazardous conditions.
How significant is their labor to the current global recycling structure?
Their contribution is indispensable. The sources reveal that these informal waste pickers collect and sort more than 3/4 of all plastic that is recycled worldwide. Yeah. In 2025, the informal sector supplied 61%. That's 17 million tons of the plastic packaging sent to recycling facilities globally. In low and middle-income economies, this contribution is virtually 100% of the recycling material. Without them, global recycling collapses.
Given their enormous undervalued contribution, what does the system transformation scenario mean for the future of their employment? And how do we ensure a just transition?
Well, system transformation actually secures and formalizes these jobs. It maintains about 19 million jobs in the combined waste sector by 2040. And the number of jobs in the informal sector is projected to increase by more than 1.6 million in lower middle and low-income economies.
An increase.
Because the demand for high-quality recycled feedstock rises so dramatically.
But securing the job isn't enough. We need fair remuneration and safety. How can policy mechanisms formalize and integrate these workers effectively?
The policy needs to start with visibility, integrating informal workers into census protocols so their numbers and capacity are accurately reflected in municipal planning.
So you know who you're working with.
Exactly. And more practically, fair remuneration and safety can be achieved through legally recognized cooperatives. These co-ops can negotiate formal contracts with governments or private processors that guarantee a minimum purchase price for collected materials, provide necessary safety gear, and ensure basic labor protections.
Turning highly vulnerable work into a formal, stable profession.
That's the goal.
Let's pivot to policy instruments that are highly visible to consumers. The case of plastic bag bans, or PBBs. These are often championed by governments, but their effectiveness appears to be highly inconsistent.
It is. PBBs, which usually prohibit ultra-thin, non-biodegradable bags, are a classic command and control approach. The data shows highly mixed success.
For instance,
They've had minimal success in enormous markets like India and China, often due to massive enforcement difficulties. Yet they achieved remarkable pollution reduction in nations like Australia and Rwanda, where implementation and public buy-in were much stronger.
what are the main critiques of these bans beyond just the consumer inconvenience factor?
Critiques often focus on the unintended consequences, especially in the Global South. Bans can increase shopping costs due to more expensive alternatives. They can trigger illegal dumping of the newly banned items if effective waste management isn't in place.
And they can be impossible to enforce.
Nearly impossible in regions like Mali or Tanzania, leading to a thriving black market for banned bags. In essence, a policy meant to reduce pollution can sometimes just shift the problem elsewhere or create new social burdens.
And we can't ignore the political reality of implementation, which often faces deep resistance.
Absolutely. Policy implementation is often constrained by the structural power of plastic manufacturers. They strongly prefer business-oriented solutions like voluntary recycling pledges over punitive governmental bans.
So they deflect accountability.
They try to, yes. And furthermore, bans are often criticized for targeting only shopping bags, which, relative to total plastic waste bottles, foam, multi-layer packaging, is viewed as a symbolic gesture. True systemic change requires considering all plastic forms and creating robust waste management systems before relying solely on bans to stem the tide.
That structural power leads us directly to Pillar 4, radical transparency and chemical safety. If industry prefers to deflect accountability, how do we force them to disclose what they are actually putting into their products?
Currently, there is a critical and frankly dangerous lack of disclosure. No existing international instrument requires manufacturers to disclose the chemicals, the additives, processing aids, or monomers they use in plastic production.
So we just don't know what's in it.
We don't.
Yeah.
And this prevents regulators and scientists from knowing about non-intentionally added substances, impurities. And it limits the ability to evaluate potential toxicity risks across the entire life cycle, from production to recycling.
This sounds like an impossible regulatory challenge. If we don't know what's in the plastic, how can we possibly assess the safety of recycling it, or even the safety of the product itself?
It's a systemic knowledge gap. The proposed solution is establishing a mandatory global chemical reporting and disclosure framework.
And that framework needs to align with a critical ideological shift.
Yes, the adoption of the precautionary principle, especially prevalent in frameworks like the European Union's REACH regulation.
Explain that transition for the learner. What is the difference between our current system and one based on the precautionary principle?
Well, currently, the burden of proof often lies with governments or researchers to demonstrate that a chemical is harmful after it has entered the market. It's a reactive approach.
Right. Prove it's dangerous.
Exactly. The precautionary principle shifts the burden of proof entirely. It requires that chemicals and materials must be proved safe and sustainable before they are allowed on the market.
So prove it's safe first.
Precisely. This means rigorous, robust pre-market testing for new chemicals, especially testing for insidious long-term health effects that defy traditional assumptions, like endocrine disruption.
Is there momentum towards creating this global governance framework that could enforce these changes?
Yes, there is significant momentum, and it marks 2025 as a critical moment. The UN is actively negotiating an international legally binding instrument, an ILBI, on plastic pollution.
The UN Plastics Treaty.
That's the one. This aims to move away from fragmented regional regulations toward a comprehensive, globally enforceable legal agreement. And crucially, the new Intergovernmental Science Policy Panel on Chemicals, Waste and Pollution, established in 2025, is now tasked with integrating cutting-edge science directly into this global policy process to inform the treaty's final text.
If plastic production and consumption are globalized, trade policy must be part of the solution. But the sources indicate trade is currently undermining the transformation. How so?
Trade policy is deeply interwoven. Nearly 78% of all plastic produced is traded internationally. The hurdle lies in structural economic disincentives.
What kind of disincentive?
The sources reveal that non-plastic substitutes materials like glass, paper, aluminum, or natural fibers face tariffs that are, on average, double those applied to conventional plastics.
Wait, so the global economic system is actively penalizing companies that try to make an environmentally better choice.
Exactly. This isn't just an abstract tariff figure. It means that every time a manufacturer chooses a paper carton over a plastic bottle or natural fibers over synthetic textiles, the current international trade system is making that choice significantly more expensive.
It's a built-in bias for plastic.
It is. This preferential trade treatment for conventional plastic disincentivizes the scale-up and market penetration of safer, more sustainable alternatives. The ILBI must integrate policy coherence where trade and investment actively align with the goals of reduction and sustainability.
We've covered policy, production, and transparency. Now let's pivot to the tangible efforts to clean up the decades of legacy pollution that is already out there and the groundbreaking science happening behind closed doors.
This is the innovation front. While prevention is the priority, we cannot ignore the scale of existing pollution. Estimates suggest there are between 75 and 199 million metric tons of plastic currently polluting the ocean.
And that doesn't just vanish because we stop polluting tomorrow.
Not at all.
The Ocean Cleanup is the most famous large-scale intervention. What is their mission and their strategy, particularly with their technology like System 03 in the Great Pacific Garbage Patch?
Their ambition is massive: to remove 90% of floating ocean plastic by 2040. They use large U-shaped barriers, System 03 is the current iteration, that act as artificial coastlines. They passively concentrate the plastic as the system moves through the water.
And they focus on the floating stuff.
They specifically target the floating plastic, which is typically lower density material like HDPC, LDPE, and PP, because this is the fraction that takes decades to break down into those dangerous microplastics. By removing the large stuff now, they eliminate the microplastic source of the future.
The skeptical question here. Does removing that plastic actually generate the net benefit, or do the operational costs, fuel, vessel GHG emissions, ecosystem disruption, negate the environmental good?
That's a critical question that needed rigorous scientific assessment. And studies focusing on the North Pacific garbage patch conducted a net environmental benefit assessment.
And what did they find?
They concluded that the ecological benefits of removing the plastic, particularly the avoided harm to seabirds, marine mammals, and zooplankton, significantly outweigh the environmental costs associated with the cleanup operation itself. Cleanup has a net positive impact, provided mitigation measures are strictly followed.
You mentioned mitigation measures. How does the ocean cleanup address the concern about incidental catch, the unintended capture of marine life within their massive systems?
They employ adaptive management. The system is designed to move extremely slowly, slower than a walking human, to allow most marine life to swim out. They use environmental observers and underwater cameras to monitor interactions.
And they've made design changes.
Crucially, yes. They introduced the new Marine Animal Safety Hatch, or MASH, on System O3. This is a mechanism that can create a temporary opening to allow larger animals to exit the collection zone while preventing the loss of the collected plastic catch. It minimizes the ecological footprint.
Beyond the ocean gyres where the pollution accumulates, what is the strategy for intercepting plastic closer to the source?
That's the strategic brilliance of the interceptor systems, which target rivers.
Right.
Research identified that a specific relatively small number, around 1,000 rivers, are responsible for funneling 80% of all plastic flowing into the ocean annually.
So you go where the flow is concentrated.
Exactly. By deploying autonomous interceptors in these high-impact rivers, the flow of new plastic input is halted, preventing it from ever reaching the massive, costly accumulation zones in the open ocean. It's a highly targeted, cost-effective prevention strategy.
We've covered floating and river plastic. What about the estimated 10 million tons of plastic that sits silently on the seafloor?
That requires deep-sea innovation. The SeaClear 2.0 project, supported by the EU, is developing integrated solutions using autonomous vessels, underwater robots, and drones.
And what do they do?
These systems use AI to identify litter, including heavy objects like tires and dangerous non-biodegradable ghost nets, and then remove it from the seabed. This specifically aligns with ambitious targets, like the EU's goal to reduce plastic litter by 50% by dealing with the plastic that conventional surface efforts can't reach.
Now for the final frontier. The biological solutions. Are microbes and enzymes truly nature's answer to plastic durability, or is this just theoretical science?
It is rapidly moving from theory to reality. It suggests natural evolution is already adapting to this new human-made material.
How so?
Scientists have found genetic markers associated with PT-degrading enzymes, specifically PTase, in over 75% of ocean water samples collected globally.
75%.
Yes. This is compelling evidence that microorganisms are evolving at a rapid pace to utilize plastic, which is essentially pure carbon, as a survival food source.
That's global scale adaptation. Have scientists been able to discover or engineer even more powerful versions of these enzymes for industrial use?
Yes. In deep-sea hydrothermal sediments, researchers discovered a novel archaeal PTase called Guapaguaymas PTase archaeal. This enzyme is particularly robust because of the extreme conditions of its discovery site.
And it works even better with a partner.
Right. When guapa is chemically paired with a second enzyme, biotase, it significantly improves the hydrolysis, the chemical breakdown of untreated peat film, by 68%. The surrounding microbes are likely metabolizing the resulting degradation products, proving a natural ecosystem link.
So we find the best natural tools in the deep sea, then we take that blueprint and supercharge it using synthetic biology.
Precisely. Synthetic biology is the key to scaling this. Scientists are accelerating the evolution of these plastic-degrading microbes in laboratories, engineering them for maximum efficiency and safety. The goal is to create specialized recyclers that can break down multiple types of plastic efficiently for deployment in controlled industrial settings.
And the quality of the recycled product.
That's the key. These enzymatic processes can break PET plastic down into its pure monomers for high-quality, food-grade reuse, achieving impressive efficiency rates of up to 90%. And this avoids the high heat and pressure required by traditional chemical conversion methods.
What's fascinating here is the sheer overwhelming breadth of solutions required. We need coordinated global policy that enforces radical chemical transparency and recognizes the powerful informal economy, while simultaneously needing groundbreaking technology from autonomous seafloor bots to accelerated enzymatic digestion to deal with the mess we've already made.
That's the definitive takeaway. The plastic pollution crisis is fundamentally a systems challenge that cannot be solved by a single tool. It requires a hard prioritization of upstream action-reducing production by eliminating virgin subsidies and prioritizing reuse alongside the highly specialized, costly, but essential downstream interventions.
And everything has to work together.
Everything. And crucially, we must harmonize global trade, chemical regulation, and social justice requirements to make the transformation equitable.
It feels like 2025 is a definitive inflection point.
Yeah.
The pathway to an 83% reduction in pollution by 2040.
Yeah.
The system transformation is known, it's documented, and it's technically achievable.
Yeah.
It demands radical transparency about chemical inputs, prioritizing reuse over every form of recycling for packaging, and formalizing the essential work of those 12 million waste pickers globally through just policies.
And we are seeing the structural foundations being built for the first time, from the UN Plastics Treaty negotiations, which could redefine global manufacturing law, to the formation of the new Science Policy Panel. The challenge is successfully integrating all these moving parts. The global governance framework, the scientific breakthrough in enzymatic recycling, the targeted deployment of river interceptors, and the policy push for mandated return and refill-based reuse systems into a coherent, equitable, and effective global machine before 2040.
So what does this all mean for you, the learner? You now have the playbook, detailing the crisis scale and the required multi-pillar transformation. The next time you grab a cup of coffee or shop for clothes, remember this central finding. The greatest potential for reduction, 2/3 of the total cut in packaging pollution, comes from simply choosing reuse over single use. The playbook exists, but the timeline is tight. Do you believe that individual consumption behavior can change fast enough to meet the urgent 2040 deadline, or will systemic change only happen when global policies force the hand of producers? That's something for you to mull over until our next deep dive.